Hi, everyone. My name is Sam, and I'm from Semmle, the company behind LGTM.com. And today I'll be talking about how you can use LGTM to find and prevent bugs in your source code. So you're all quite familiar at this point, I'm guessing, with what the general process is when you find a bug. It's discovered or reported, you find the underlying cause, you fix it. And then, not too much generally happens after that. You might close your eyes, cross your fingers, hope that it doesn't come up again. But usually that's not the case. Semantically similar mistakes are made time and time again, and it's then up to code reviewers to remember to manually check for certain mistakes with each review that comes in. But this can be tedious and impractical as, over time, the number of mistakes you need to remember increases as the project grows. The number of developers who are involved increases. You're reaching deadlines and code reviews are rushed, and it'll get more and more difficult. So mistakes can slip through the cracks, and you don't always find everything that you should, things that are problematic in the past. So there must be a better way of dealing with this. Something that allows you to find all the existing variants of a particular mistake in your code base. Like one mistake might be indicative of many other similar mistakes being made elsewhere. And there should hopefully be a process that will also prevent these mistakes being introduced again in the future. And that's basically what we do at Semmle with QL and LGTM. So security teams at all of our customers, such as Google and Microsoft, Mozilla and NASA, use QL to take existing known vulnerabilities from multiple sources, such as bug bounty programs, incident reports, other known vulnerabilities in the past, sometimes other code analyses, and they'll write queries to find all variants of that vulnerability elsewhere in the code. Often these are exploitable 0 days, and what they then do is they run these queries continuously to prevent the reintroduction of these mistakes elsewhere in the code in the future. Furthermore, these companies are also contributing these queries back to the community through our centralized repository of open source queries that all projects on LGTM run and are also run at all of our customers. And it helps other teams outside of their organization avoid making the same mistakes. So to give you an example of how this works, I'm going to take NumPy, which is a Python library that simplifies writing code that does scientific computing and has around 700 contributors. Given the nature of the library, it's very important that computations are as efficient as possible and they're also as accurate as possible. Given the size of the project, there's a lot to consider and many different conventions to take into account. These are conventions that have been added over time. And keeping everyone up to date, all the contributors up to date, it can be a very difficult task. So for the purposes of this presentation, I'm going to be working with a pretty simple syntactic example here. But the same technique and process can be used to catch mistakes that are a little more involved and require queries that look over many different parts of the source code, performing global data flow, taking into account semantic information, and all of that sort of thing. So for this example, the library often calculates the length of a hypotenuse using Pythagoras' theorem by calculating the square root of the sum of the squares of certain values. So implementing the algorithm directly like this, however, can be susceptible to overflow errors given the use of fixed point integers or fixed precision integers in NumPy. There is actually already a function defined in the NumPy library called hypot that will actually calculate this value without these fallbacks, or without these drawbacks. So all the places where we calculate the hypotenuse like this, we should be using the function call instead. We can write a query in QL that will search for instances of this pattern. And given that NumPy is on LGTM, we can actually run the query directly in the browser to look for these results. So this is what the query looks like. The most important bit there is at the bottom. So it basically looks for calls to functions that are called sqrt, where the argument given is an add operation between two expressions that are the square of some value. And when we run this query on LGTM, on SciPy, we get 18 results. And these are all of the instances of this mistake made on the code base. It turns out most of these instances are in test code, but there are 2 instances which are not, including the one which I showed earlier here. So now that we've found all the current variants, we can start eradicating them and start fixing them. But how do we actively prevent them from appearing again? So to demonstrate, I've made a fork of NumPy, and added the query that I just showed you that we ran into the repository, and it's checked into the master branch. Once we've done that, LGTM, also this is the path that we'll put it in, and any queries put in this folder will be automatically run by LGTM. Once we've done this, LGTM will show these results in the alert view. So if there are any results for this query, any matches, then for the head of your main branch, you'll be able to see these results. So at this point, we're able to keep track of new alerts for queries that we've written, in addition to the standard queries that we run on LGTM. But while we no longer have to manually run the query when we want to get results for them, viewing the results at this point is still a little bit too late in the process. And we can do better than this. So this is where LGTM's automatic code review comes in. To enable this for your project, you can go to the My Projects page and simply click Enable PR Code Reviews. And if necessary, LGTM will direct you to GitHub to ask for extra permissions required to do this. At this point, when a pull request is created on GitHub, GitHub will notify LGTM, and it will start running all the standard and additional checks to see what alerts will be introduced in this pull request. And as the queries are run, and as LGTM goes through the different steps, the statuses as well are updated on GitHub. Once the analysis is complete, if there are any new alerts introduced, LGTM will post a comment on the PR that details the alerts, and you can click on the links in the comments or the commit statuses to see more details about what LGTM has found. And this will show you the alerts in line with a diff of the PR. At this point, you can fix the alert, update the pull request, and the new mistake never made it into your main branch. It avoided going in there in the first place. So we have a much better story now. Once the bug is found, we can fix it, and then we can follow up with finding all other variants in the codebase and preventing new alerts for that query from appearing in the first place. But can we go even further than this? Imagine if someone else could benefit from the work that we have done here. It's likely that the query we have written could be relevant to other code bases too, and could prevent bugs in other people's code. In this particular case, the query could be relevant to any project that uses NumPy, but perhaps you've come up with a query that's a little more general and more widely applicable. Wouldn't it be great if you could share that with the world? And that's exactly what we're doing with LGTM. So all of our standard queries, of which there are about 2,000, are open source and available on GitHub under the Semmle org and the QL repository. Teams from a number of companies have already started contributing queries and improvements back upstream into this repository, predominantly in the security space, because we're a security-focused company, and that's what most of our technology is aimed and geared towards. My favorite external contribution so far has been a query from Microsoft, which finds instances of zip-slip in C# code, which is the vulnerability that was discovered by Snyk not too long ago. So once you've created queries, you can contribute them back up to this repository and let the whole world benefit. So it's no longer just you who can benefit from benefit from this and code with confidence, not being scared of making the same mistake again in the future, but the whole software community. So we are up on the mezzanine up there in the forest. If you have any questions, would like to see maybe a few more examples, walk through the query, how that works, and would like to maybe start learning yourself, come give us a shout. We can also add your projects straight away, help you enable pull request integration, and show you the benefits of that. Thank you so much.